How's it going, everyone? Everyone doing well? Fantastic. So yes, my name is Hany Fahim. I'm the founder and CEO of VM Farms. I'm going to be continuing a series of talks called Tales from the Offside. These are interesting events that we've encountered as being the guardians of our clients' production systems. Today, I'm going to be telling the tale of the creepy crawler. So this started off on a lovely late summer's evening when our pager went off, and it was a site down for a customer at about 10 p.m. This was a large e-commerce website for one of our clients. So started looking at the issue, and right away noticed that there was very high load coming from their database server. It was MySQL based. Taking a look at the queries, we noticed that there's a lot of queries that stood out that appeared to be related to pagination. So basically somebody going through the site, clicking through multiple pages of products, for example. The site recovered on its own within 10 minutes. We didn't have to do anything. So excessive pagination didn't really seem like a human because of the volume. Could it have been a crawler at this point? We know that this customer does a lot of SEO. So check the logs and look for any known crawlers that caught our eye. We saw some from Yahoo. Although, at the time, it was about less than 200 requests over an entire hour. That's not really enough to justify an entire site going down. It was late. We wanted to get back to our summer evening, so we decided to collect as much information as we could and go back to our lives. Of course, as all these tales, it never ends there. At around 5 a.m., the site went down again. Same pattern, high load on the database server. Traced some queries to a scheduled job that was running on this administrative server. So this server basically runs the same code as the rest of their cluster. However, it is dedicated to back-end systems for their employees, as well as running some scheduled jobs to do various administrative activities. Looking closer, we found out that this cron job runs every 5 minutes. So we thought, okay, maybe somebody recently added this cron job and it was wreaking havoc on there. Everything is in source control, so we decided to take a look, and GitBlame told us that this cron job has been around for about a year. So it really couldn't be that way. Couldn't be the cause, but it still was a prime suspect. The site recovered within 15 minutes, again, on its own. Taking a closer look at the job itself, it turned out to be some cache refreshing script. So basically, it goes in and refreshes a bunch of counters and product inventories and whatnot. So it was related. It does hit the database. It still was a prime suspect, so we waited for the next execution of that script, since it happens every 5 minutes. Hit it a bunch of times, and the site didn't go down. Waited for a few more executions, and again, still absolutely nothing. But we thought, we did see that it did contribute to the load, so we thought, all right, let's put this in our back pocket. If it goes down again, we're going to disable this outright. And decided to go back to sleep. And then at 9 in the morning, 9:19 a.m., the site went down once again. Same pattern, high load on the database server, and that cron job was running. So we decided, all right, let's just terminate that thing. People can get a little bit of stale counters on there and disable the job outright. But the site did not recover. It was still down. The database server was still going absolutely nuts. So where do you look next? What is the next thing to do? Started staring at the logs. Sometimes staring works, and something caught our eye. We noticed that there was a lot of requests where the referrer field, so the referrer is basically a header that gets set in many HTTP requests, had the customer's blog in there. So basically, the traffic was coming to the blog and getting referred to the site. So we decided to group all these blog entries together to see if there's other commonalities, and there certainly was. Notice that the user agent for all of the requests that had this referrer was Baidu Spider. So Baidu is a well-known Chinese search engine. They all had the same request. They're all hitting EN, all categories, English categories. The query string was manufacturer, and it had various numbers cycling through it, so they're hitting all the different manufacturers. And of course, they're checking for things being on sale. So was it this crawler? Was it Baidu kind of wreaking havoc? We've known from our own personal experience that Baidu actually misbehaves often. It often doesn't even respect your robots.txt file to know how hard to hit your site and which ones to visit. Taking a look at all the requests, we noticed that there's over 10,000 unique IPs in the last 24 hours, all reporting themselves as Baidu. Also, these all belong to American residential ISPs like Comcast or Verizon or Roadrunner. So it doesn't seem like that. I mean, a Chinese search engine coming from American residential IPs, something's not right here. In addition, this customer mainly targets Canada, but they did have some US business, so maybe there was some legitimacy to that. And the high volume of American IPs pretty much dominated the traffic during the last few outages as well. So in this case, like the others, the site recovered on its own, and as soon as it recovered, we noticed that those American IPs stopped coming in. So very, very strong correlation over there. Because this is pretty much not Baidu, it convinced us that this was some sort of malicious traffic. So time to start blocking that traffic somehow. We wanted to be surgical, and so did our clients. Because you're blocking traffic, and this client does a lot of SEO, they wanted to ensure that legitimate traffic still came in, but you were only blocking the bad guys somehow. Because these IPs were residential and they varied a lot, it was not a good candidate to select for blocking. So we had to be a little bit more creative. So our surgical blocking followed this criteria. If anything came in and it had this EN, all categories, the user agent was Baidu, it was checking for things that are on sale, and had the referrer of the customer's blog, all those conditions had to be satisfied. That was enough to catch it. And when we were testing, it was pretty much just narrowing the particular request we wanted. So it seemed good, sat and wait, see what would happen next. And of course it did. 4 hours later, we checked the logs and our rules were not being matched anymore. The American IPs are still coming through, but now the referrer field is empty. So they're no longer coming through the blog, or at least disguising themselves as coming from the blog. So they're adapting. There's an active attacker on the other end, and they're adapting. We could tell because when we were looking before, we could see that our block was actively working. And they're trying to cycle through different categories until they finally found it, hey, let's just remove the referrer, and all of a sudden they made them so that they got through. All right, fine. So let's remove this referrer condition. Not as preferable because now you're getting less surgical with your block. And again, the client was expressing a lot of concern. They didn't want to block legitimate traffic. But the moment we did that, it started blocking again and the site recovered. Okay, well, at least stability is better than the site being down. Sat and wait one more time, and the next day at 10:50 a.m., the site went down again. Checked our logs, and it was the same request pattern, same American IPs. Still an empty referrer, only this time it was not Baidu Spider coming in. The user agent was changed to Chrome, and this was the user agent that was being reported. What was curious about this one in particular is this version that it was reporting was about 6 months old at the time, which is kind of odd. The next odd thing was that all the requests had the exact same user agent, exactly, even matching the map. So they were all mapped with the exact same version of Chrome, which is odd because we all know Chrome is pretty good at auto-updating and it keeps things moving very quickly. And this version had known vulnerabilities, so we thought, okay, maybe somebody found all the vulnerable versions, that specific version, and was using it to exploit. So taking a look at the exploitations there was this one called Gyrophone, which is actually really neat when you read into it. So the synopsis is basically gyroscopes found on modern smartphones are sufficiently sensitive to measure acoustic signals in the vicinity of the phone. So basically, when your phone and you go to a browser and it wants to access your microphone, it needs your permission to do so. So you can't just start listening in on conversations. What they found is your phone has a bunch of gyroscopes in there, and they're so sensitive that they can actually detect sound, and through software they can actually construct voices. So it can actually listen to you without a microphone at all, which is really neat, except not relevant to our issue at all. It doesn't seem like this is the issue. All right, so strange that they're all the same. It's possible, but unlikely. And again, our client was really hesitant. They didn't want to take more drastic actions. So we just adapted our conditions to also match on this Chrome version, and of course the site comes back up again. 1.5 hours later, this guy's getting faster. Site went down. Different pattern this time. Now he's hitting a different endpoint. Instead of all categories, he's hitting gear equipment. Same American IPs, same user agent. So we got on the phone with the client. We're like, all right, listen, this guy is actively trying to take your site down or doing something malicious. Let's just block this entire user agent. Remove all the other conditions and just match on this particular Chrome version, because for some reason they stuck to this version over here. Maybe they couldn't change it. So the client was hesitant because they're like, we're going to block some legitimate customers, but at least it's a small price to pay for stability, and they use that a lot. Site recovers immediately. 3 hours later, it goes down again. Same American IPs, same request, but now a new user agent. So this was the user agent being reported. Interestingly enough, it's now Linux instead of Mac. And what the heck is this version? This version makes absolutely no sense. It's not a legitimate version. It's completely invalid, and in fact, the version numbers were varying a lot. They were changing constantly. Okay, fine. You want to play? Let's play over here. Let's crack open some regular expressions. Regular expressions, for those of you who don't know, it's basically pattern matching using some funky syntax like this. This basically means matches 4 sets of 6 or more digits that would match something like this. Chrome would never match this, but it definitely matches if you try to use this weird invalid version. Site recovers immediately. All right, let's do this. Bring it on. Let's see what else you got in your pocket. 1 hour later, goes down again. This time, switch to Windows and Chrome version 0. I mean, come on. Got to get a little bit more creative than that. I mean, honestly, what they had to do is just use legitimate user agents. Just grab a list of legitimate ones and cycle through it. That would have been a lot harder for us to do that. They made our job very easy. Okay, so let's adapt to this. Let's block 0 as well. Site recovers. I mean, we could just do this all day, right? And then silence. Nothing for a while. 2 days later, it did come back though. At around 12 a.m., site went down again. This time, things looked really different. There was nothing in the logs, and when I say nothing, I mean there was no traffic coming in. It completely stopped. The database server was also not loaded. It was loaded this entire time, but this time it was not doing anything. It was actually completely underutilized. The app servers, on the other hand, were screaming. They were extremely high load. They were never affected during this whole time. This time they were. Every app process was consuming 100% CPU. So was our attacker getting very sophisticated and upping their game? Well, time to crack open one of my favorite tools called strace. Strace, basically, in a Linux system, you have user space and you have kernel space. All your applications run in user space, and the kernel is responsible for anything related to the system. So when your app needs to make, like open a file or access the network, it's got to make system calls to the kernel, and that's what strace watches. It watches all system calls going through. So we attached strace to their PHP FPM processes, and it gave no output, which is really odd. If anybody's ever run strace before, they know that it spews endless amounts of too much information. Well, it can fill up your buffers very, very quickly. The fact that it produced no output is extremely odd. I thought strace was broken on the system when it did that, but it wasn't. So, all right, it's producing nothing. Everything is streaming. Let's just restart the systems and see what happened. Just do that. It's very Windows-esque. When we did that, we watched the logs, and we saw requests started to come in, and then they stop again. And the CPU spiked back up immediately. Check quick analysis, we figured out that there was about 200 requests since we did the restart. And doing some math, they had 20 app servers, 10 processes each. That's 200 processes that it can do. Does this mean that every request that comes in somehow locks up PHP FPM processes? What was our attacker up to? This is a very strange one. So we had to isolate one of the servers to troubleshoot further. So we took one server out of the load balancer. We configured it to say anything coming from our own IPs, I want to direct it to that one server that I took out. Reduced the process count to 1, so therefore I only have 1 process to watch, and I attached strace and loaded the site in the browser. And as expected, tons of data flowed through on the screen. And at the end, we noticed that there were some calls to the database, and then a call to Redis, which they had in their cluster, and then nothing. It hit Redis and then nothing again. It's not very usual. And the CPU spiked, so it was doing something, but no system calls. So could it have been Redis, since the Redis was the last call being made? Nope, the server was actually perfectly fine. Just like the regular database server, it was very healthy, not breaking a sweat. It was underutilized. Decided to turn on this slow request logging feature of PHP FPM, which is actually a really great idea, and I wish more web servers did this. Basically, you set a threshold and you're like, any request that takes longer than this, give me a stack trace. I want to see where the request is going. And the moment we turned that on, we figured out what the culprit was, which is this nice stack trace. It's the top of it. It was basically this function in this file at this line number over here. So what's on line 36? It was basically a while statement going through, and it was getting stuck on this particular condition. Basically, this condition is always being satisfied over and over and over again. When you get to the stage, what you do is you add some print statements to debug, right? My favorite tool. So looking through this, trying to figure out what is exactly being satisfied, we figured out that code was manufacturer, the string manufacturer. Unkey, whatever unkey is headhouse, and headhouse is actually a manufacturer of hats. And this entire hash returns this number, which is a product code. Okay, that's understood, and that's why it's always being set. It's always being satisfied. It's returning the same thing. If you take a look at the next thing, the very short function, it basically takes that unkey and it's supposed to append something called special character to it constantly and runs through the check again. So basically, it goes through it over and over until it finds, until it basically gets returns false and breaks out of the loop. Except when we were checking, this value of special character was returning nothing. So when it returns nothing, it doesn't append anything, and it just keeps checking the same thing over and over and over again. So this is why we're looping. We're basically stuck in an infinite loop somehow. The weird thing is we went to the database and we found that special character is set to dash, which means that headhouse on the first iteration should come around and be headhouse dash and then dash dash and etc. Except it's not. Looking at this particular function over here, we notice that this one is fronted by a Redis cache and then it gets cached in memory. So we checked, all right, what's in Redis? Redis returned nothing. So the database says dash, Redis should cache it, and Redis turns nothing. Did our attacker somehow compromise our Redis server? This is very confusing over here. And then the site recovers on its own without making any change whatsoever. Did a time check, and it was 3 a.m. At this point, the site was down for 3 hours straight. When we checked what our print statements were showing, now somehow this thing is returning dash like it should. And our loop is broken because of that, because that's what it's supposed to do. Somehow, we didn't do anything. Neither did the client. But the moment we mentioned, hey, it's 3 a.m., this triggered their memory, and they're like, oh yeah, you know what? This admin server has a scheduled job that runs at 3 a.m., and it clears out the entire cache. They also have a job at 12 a.m. that refreshes the products. And the site was down from 12 to 3 a.m. Okay, it doesn't really smell like an attack anymore, right? Maybe this is some sort of weird application logic, although none of this has been touched for quite a while, at least the logic here. So it was really late at night. We were very tired from all this attack traffic, decided to go to bed. In the morning, our customer had done a lot of work for us. They realized that the previous day, during those days of silence, they had updated several components of their application. New versions of the components had reported some performance improvements, and they were doing this because they wanted to make their app more resilient in case there was more attacks coming through. One of them included this function, this module called PHP Redis. The best part, the client was able to replicate this in their staging environment, which is such a treat. Very rare that you have a production problem that you can replicate in staging. They're able to turn it on and off on demand. They're able to run this refresh script. They can break the entire site. They can run the cache clearing, and everything recovers again. So what exactly was this refresh job doing? Well, it's very simple logic. The first thing it does is it clears a bunch of cached entries, like special character, so it's empty. And then it reads a bunch of attributes and refreshes the catalog. Really, really simple. So putting some print statements, let's see what the heck this thing was doing. Turns out that this thing was returning garbage. It looked like it was binary data. Somehow it was returning binary data, which it didn't really understand. Well, it turns out that new version of PHP Redis that they updated supports compression now. So it was compressing everything. That binary data was actually compressed data. And the admin server was not updated. They were focused so much on the main cluster for their clients that they wanted to improve the performance for them, they neglected the admin server because, you know, their back-end employees, they can deal with the slow site. Well, when it grabbed that value to do the parsing, it couldn't understand what this binary data was, so it crashed, leaving special character unset and therefore breaking the entire site for everyone. Updating the admin server fixed the problem permanently. Funny thing is, this attacker never came back. After this ordeal, they never came back. And talking to our clients on the phone a few months later, they had noticed that their own content started appearing on other e-commerce sites and blogs, and they knew it was their own content because they actually have their own photography studio where they take pictures of their own products, and they could recognize that. And a lot of these sites resolved to sites in Russia and into the Ukraine and China, so even jurisdiction was difficult to enforce. But the client decided, you know, they were going to try some legal means to get back after them. During this whole thing, so due to the lack of sophistication in the scraping attempt, right, just trying to change a couple things in the user agent, like I said, if they just used legitimate ones, it would have made our lives a lot harder, which is fairly low skill. And the access to a very large number of compromised systems. In the end, it was over 50,000 systems, which is actually a high skill. It requires a lot of work to do that. What is likely is the attackers were renting some sort of botnet, which is something that they report on quite often, and it's actually really cheap. The last I checked, it's something like $50 an hour to rent an entire botnet. And it was in an effort to steal their content in a rapid fashion and then try to go and set up some scam websites to try to sell you all these products. Some lessons to be learned. Heavy applications are vulnerable. And when I say heavy, I mean very large, complicated systems that are slow to process. So there's actually more benefit to making your site faster than just making a good user experience. It actually makes you more resilient to attacks. Sometimes staring at logs work. Sometimes. When we were stuck, we were just streaming and watching, the matrix fly by, and all of a sudden you start identifying some things. It works, but not always. And last thing is strace, which is very verbose. When it tells you nothing, actually tells you everything. If you know that the app is making a lot of is doing something, but there's no output, it's all application code, 100% guaranteed. That's everything. Thank you. Any questions at all? No questions. That's unusual. Okay. Steve?
So, let's say, in the different moves towards more sources of learners, scaling, what are you guys doing to sort of make it not, like, aim it out sort of together with your advice so that you avoid scaling and you're going to screw up that up and then you really have much harder to
So I guess the question is related to serverless environments or just auto-scaling? Because it could be either. I mean, auto-scaling sometimes can bite you often because of this very reason. Sometimes it's due to malicious activity can cause CPU spikes, and all of a sudden you're paying a lot more. Not only is your site potentially going down during this auto-scale activity, but you're also paying a very large bill, and sometimes you may not even notice that your bill just went up. You thought, hey, maybe it's just regular traffic. I mean, it's very difficult. Personally, I like to set up some alerts whenever auto-scaling triggers, so then you can investigate and also put some limits around there. So say you can double the size, but then that's it. And once it hits the limit and it still wants to go, a human needs to take a look and see what's going on, because it could be maliciousness, or it actually could just be a bad deploy. We've often seen sometimes where you push a system, it passes everything in your QA environment, but then it has limits and scalability in when you deal with production traffic. So usually putting around limits to auto scaling is usually what we want to do. I usually say about double, and that's it. Serverless environments are very strange. I mean, you still have database systems behind there. You still have other components. And throughout this whole time, except at the very end, the database was really the big issue, which is way harder to scale. There's a lot of issues with that, especially if you have a monolithic database that pretty much has all your data. Those are usually the most vulnerable in there. You kind of want to plan ahead and cut it into pieces as much as possible to isolate the components. So it's really hard. You have to put limits and try to be smart about it, and maybe do some testing as well to see if you can push your app and how it reacts when you get a lot of traffic.
So around have you guys implemented any kinds of automation since this incident to sort of analyze the patterns early on, or try to detect this in advance, or mitigate it?
So have we added any automation to kind of prevent systems like this, issues like this happening?
The attack.
Sorry?
The attack.
Attack specifically, so yeah, I mean, I talk a lot. So many of my talks deal with attacks because it's an interesting topic and it throws you for a loop. Um, Oftentimes, we highly recommend that our clients use Cloudflare. So a lot of the times, Cloudflare is a fantastic tool because they have a very extensive network. They see a lot of malicious activity, and if they detect some new attack pattern come in, they'll push rules across the entire board. And because they benefit from the community and their entire customer base. So oftentimes we push very strongly to use Cloudflare as much as possible to protect themselves from there. I'm not sure. Well, they probably would have caught those invalid user agents, especially if the volume got really high. They probably would have blocked it. We would have seen that. Who knows what attack vector they would have taken if they were smart enough. But usually Cloudflare is a good option in there. Usually, just making your app resilient is also a good strategy because I don't total volume was high, but it wasn't like crippling. But because their app was so heavy, any small requests to pages that weren't even cached just were enough to topple the whole thing. So you throw that, a few thousand requests, and that's enough to take you down. So also doing performance improvements helps. Cloudflare and just being smart about that. That's what I would say. Yes.
So you had a couple of others. What is the potential process you follow when you have experience with the client?
When you have,
What do you experience with the client?
when we share with the clients.
Yeah. What do you typically do? Like, what do you experience?
I mean, so our typical process is first thing we do is open a ticket with our clients and do some initial investigation. Because we standardize on how we build systems, it's really pretty easy to figure out, and all our team is trained. So it's pretty easy to figure out where the problems are because you're very familiar with all the different patterns that we deploy with. Usually, if it's something that we can fix, we fix it and we notify the client that it was fixed. In cases like this where it's a little bit of a head scratcher, you start calling the client. You get them involved because they know their app the best. We know the systems and kind of work in collaboration. Now we also make use of a lot of chat with our clients as well, so we are actively in chat with them, going back and forth, sharing information as much as possible to kind of get as many brains on the problem as possible. Most issues are really simple to resolve. They're about 5 minutes. Okay, this thing crashed and it ran out of memory. Tune this thing and start it back up and go to bed. So it's usually informing the client and getting them on the phone if there's a major issue that requires their brains. And also asking them what changed. In this case, they should have told us that they made some changes to their app that could have saved 3 hours of work. Yes?
So basically, the attackers were scraping the site
Yes.
and cloning it.
Essentially, or just stealing the products, and they wanted to see what things are on sale. They probably wanted to see what the prices were, set up some fake e-commerce sites, take your money, and never deliver.
So you said the client was pursuing legal means.
Yes.
Any
As much as
traction or
possible.
headway there?
I have not followed up with them. I'm going to say no, especially because many of their sites were hosted in other countries that are outside of your jurisdiction. There's very little you can do about that. You can't really prevent them from doing that. Yeah, you can try to contact the ISP, but again, because they're outside of your jurisdiction, who knows if they're going to listen to you, right? Who knows who's legitimate in this case, right? If you're like, hey, they're stealing my content, they're like, all right, prove it.
You can hire a botnet and put them out of business.
You probably could, yeah. If you're familiar with the dark web, you can probably attack them back, right? Yes. Yes, all the way in the back. You may have to. This thing is really loud. You may have to come over here. Someone here in relay. Do you want me to bring the microphone? Is there a proxy that can relay?
What port number?
IP tables? Is that used to block, you mean? Rate limit by subnet? Through IP tables, right? Using IP tables as a blocking mechanism? Is that right? IP tables? Thumbs up? I'm going to answer the question anyway. IP tables, it can work, except IP tables works at layer 4 of the OSI model, so you don't have a lot of information using IP tables to do that. Is that your question? Yes? I'm going to use it anyway. So you could do that, but because the IPs were very large and varied, it was very difficult to isolate them. Basically, when we were doing an analysis, every IP got used about 3 times, so it made about 3 requests and then cycled away. So keeping track and keeping up with them, I mean, you're going to be, at best, if you're keeping up, you cut the traffic by maybe about a third or so if you're that fast to respond. Using other techniques like higher up in the stack, I mean, in this case, we just have to take a look at the user agent. I mean, they're silly enough to put in some illegitimate user agents to block. You can do it, so we do use that, and it's effective if the number of IPs are small and stay relatively static, which does happen. IP tables is very effective at blocking them, so you can just select them and block them right away. So you can do it in that case, but if they're cycling a lot, it's much harder to do that. You have to pick somewhere else to figure out where to block. That answer? Yeah. Cool. Any other questions? Are we done? All right, thank you. Thank you.